Alright, my name is Alex Birch. This is me. And I worked with 4 fools for my astronomy project. This is Steve, philosophy major, and he knows Play-Doh. And making the sun out of food is kind of like playing with Play-Doh. Alright, number 2, we have Mary Block. Her face isn't very pretty, and either is her major, which is English. Next up, we have Roger Porres, with a major in cat bar loitering and a minor in English. This guy is one creepy dude. And lastly, we have Sarah Bowes, with a history of train wreck relationships. Her head may as well be a bowl of mashed potatoes. And, by the way, her major is theology. Alright, for our project, we chose to make the sun out of food products. The sun essentially has a core and 4 outer layers. The core we will represent with meat. The layer after that, the radiation zone, we will use mashed potatoes. After that, we have the convection zone, which we will use pancakes for. After that, the photosphere we will represent with pie crust. Lastly, the chromosphere will not be represented because in real life it's not visible, kind of like Stephen's manliness. Okay, here Steve is doing one of 2 things. He's either trying to catch a bubble, or he's trying to physically grasp the Platonic form of manliness, which he lost a long time ago. Okay, about that chromosphere. It's the outermost layer of the sun, and once again it's invisible. It is also the sun's atmosphere. Interestingly, its density increases the closer to the photosphere you measure. It is also partly transparent, and is named for its reddish color. Surprisingly, it is actually hotter than the photosphere, although it is further from the core, sometimes reaching almost 20,000 degrees Kelvin. The chromosphere is only observable during a solar eclipse, or with a special filter.
So this is all the giant molecular cloud of stellar ingredients. We got pie crust and eggs. Right. Mashed potatoes. We're making pancakes.
Alright, what Roger's trying to say here is that we have a whole ton of food, kind of like a giant molecular cloud out of which a star is formed. We're going to use 2 bowls, fill those up with this food, and then put them together in the end, making a star.
So pretty much we're building the structure of the sun. We got the photosphere here.
Alright, that pie crust, that's the photosphere. It's the second layer from the outside of the sun, and it's what we actually see when we look at the sun. It is composed of pockets of gas called granules. These granules have a lifetime of about 8 minutes, and they're about 1,000 kilometers in diameter, with hot gas rising in the center, and cool gas following in the narrow spaces between the granules. Its temperature ranges from 4,500 degrees Kelvin to 6,400 degrees Kelvin. Blobs appear on the photosphere, where the heat from the sun's inside escapes. Kind of like the oatmeal I ate for breakfast this morning, which I then put vodka into, after remembering I had to work with these guys today.
In the meat, what is the meat for?
The really awesome core
Of the sun.
of the sun. Look at this, the magnetic zone that is creating a sun.
Ignore her, she has no clue what she's talking about.
You are looking at the sun too long.
Don't even look at the sun with sunglasses on unless you have 4 pairs.
That's the
Alright, convection zone going in.
Don't touch it, it's hot.
It's really,
you know what we didn't think about?
What?
This is how stars are made.
Alright, that pancake batter is also known as the convection zone. It is the next layer of the sun and stretches for approximately 200,000 kilometers. In this area, solar material travels up through the thermal columns to the photospheric surface when it is hot enough, and then back to the core when it is cool so it can be reheated. Solar material, or plasma, must move through this zone to vent its heat, because it is not dense enough or hot enough to conduct thermal energy through radiation. This is a vital process for maintaining the temperature of the sun. Alright, that's the finished product of our convection zone and photosphere. It looks pretty disgusting. And it was pretty disgusting. Looks like these guys are having fun. What's it got to do with astronomy? Nothing. Alright, those mashed potatoes, that's the radiation zone. From about 1 to 3/4 of a solar radii, it's hot and dense enough that thermal radiation is sufficient to conduct the intense heat of the core outward. No convection occurs in this zone. With increasing altitude, the temperature and density decrease rapidly, somewhat like my opinion of Mary Bloch about 2 seconds after I met her. Alright, and finally, that piece of meat, that's the core. It's about 25% of the solar radius. In terms of density, it is about 150 grams per centimeters cubed. If you want an image of that density, just think of Mary Bloch's skull. In terms of temperature, it's about 13.6 million degrees Kelvin. The core is where 99% of the energy in the sun is produced, which occurs through the proton-proton chain. The energy travels outward through the rest of the layers and heats them. When it reaches the solar photosphere, it escapes into space as sunlight. Alright, it's not that exciting, but in case you didn't notice, that's our sun. Alright, I'm going to take the next couple moments to explain how the sun formed scientifically, something I kind of skipped over earlier. The sun formed out of a giant molecular cloud, left over from supernova, or a planetary nebula. This giant molecular cloud, composed mostly of hydrogen, eventually became dense enough that gravity could work on it. Due to this gravity, the cloud shrank to form a spinning disk. While shrinking, the temperature in the cloud increased, which led to the gas becoming plasma and to the beginning of nuclear fusion. The forces of gravity shrinking the cloud, and nuclear fusion putting outward pressure on the cloud, led to pressure equilibrium, and so our star was born, a balancing act between inward and outward pressure, sustained by fusion.